how do I, practically speaking, how do I do this? Anybody have an idea? How do I keep P1 constant while I'm lowering the volume? Change the temperature, right. So what I'm doing here is I'm cooling. And then when I'm sitting at a fixed volume and I'm increasing the pressure, what am I doing? I'm heating, right? So I'm doing cooling and heating cycles. So in this case here, I cool and then I heat. In this case here, I heat and then I cool. Right? So I'm burning some energy, burning some fuel to do this somehow, okay, to get that work to happen. All right. Now suppose that I took these two paths and coupled them together. So in this case, it's the amount of work is the area under that curve. And in this case here, the amount of work is bigger. W2 is bigger. And it's the area under this curve here. Now suppose I took these two paths and I coupled them together with one, the reverse of the other. So I have my initial state, my final state, my initial state, my final state here. And I start by taking my first path here. I cool, I heat. So that's W1. So the W total that I'm going to get is W1. And then instead of the path from V1 to from 1 to 2 going like this as we had before, I'm going to take it backwards. Okay. If I go backwards, the work, everything is symmetric. The work becomes a negative for what I had calculated before. So this becomes minus what I calculated before for W2. Right? The total work, in this case here, is P1 times V1 minus V2 minus P2 times V1 minus V2. It's P1 minus P2 times V1 minus V2. This is a positive number. P1 is smaller than P2. This is a negative number. The total work is less than 0. That's the work that the system is doing to the environment. Okay? I'm doing work to the environment. The work is negative, which means that work is being done to the environment. And that work is the area inside the rectangle. What you've built is an engine, right? You cool, you heat, you cool, you get back to the same place, but you've just done work to the environment. You've just built a heat engine. Take fuel, or rather you take something that's warm and you put it in contact with the atmosphere, it cools down. You take your fuel, you heat it up again, it expands. You change your constraints on your system, you heat it up some more. Then you take the heat source away and you put it back in contact with the atmosphere and you cool it a little bit, change the constraints, cool a little bit more, and heat, and you've got a closed cycle engine. We're going to work with some more complicated engines before. But the important part here is that the work is not 0. You're starting at one point, you're going around a cycle, and you're going back to the same point. The pressure, temperature, and volume are exactly the same here as when you started out. But the W is not 0. W, for the closed path, and when I put a circle there in my integral, that means a closed path where you start and end at the same point. Right? This is not 0. If you had an exact differential, the exact differential around a closed path, you would get 0. Wouldn't care what the path is. Here, this cares what the path is. So work is not a function of state.